Okay, you guys, we're now going to take a look at exercise 6-8 on page 350. Here we're calculating the present value of some annuities. And remember, annuities are just equal cash payments over time. It says using the appropriate present value table and assuming a 12% annual interest rate, determine the present value on December 31, 2016 of a 5-period annual annuity of $5,000 under each of the following situations. So our present value we're calculating, the money's going to be received in the future. We want to know what it's worth today, or not today, assuming today is December 31st, 2016. Okay, so let's read the first situation. The first payment won't be received until December 31st, 2017, and interest is compounded annually. Okay. In this situation, the future payment amount is what, $5,000 annually. I should probably put annual future payment amount. And you should probably space between those as well. There we go. Alright, now what table are we going to go to? Well, it's 5 years, and this first payment on number 1 is being received at the end of the first year. We're starting on December 31st, 2016. We're not going to receive the first $5,000 payment until 1 year later. If the payment's received at the end of the year, it's an ordinary annuity. So we go to the table present value of an ordinary annuity of $1. And that's in the appendix P in the back of your book. We'll flip over, that's on page. Hard to get those last few pages to open up. I'm all thumbs here. Okay, present value of an ordinary annuity, that's on page P-4. Okay, our interest rate for the year is 12%. We're dealing with 5 years, 5 interest payment periods. So the present value, what is $5,000 received 1 year from 12/31/16 every year for 5 years. So it would be received on December 31st, 2017, 18, 19, 20, and 21. So what we'll do is come across to 12% and down to 5 periods on the present value of an ordinary annuity table, and I get 3.60478. We're going to multiply that by the amount of the annuity each year, $5,000. So what they're saying here, if $5,000 is invested 1 year from this date, 12/31/16, so $5,000 is invested on 12/31/17, 18, 19, 20, and 21. How much is that actually worth to us today on 12/31/16? Assuming an annual interest rate of 12%. Well, if you multiply 5,000 times 5 is $25,000, but that $25,000 to be received in the future, assuming this annual interest rate of 12% is only worth $18,024 to us today. Today being 12/31/16. Okay, our next situation, the first payment is received on December 31, 2016, and interest is compounded annually. Okay, here, the first payment is received at the beginning of the year. So that makes it an annuity due. The annual future payment amount stays at $5,000. This time, though, we go to present value of an annuity due. Of $1. That table, present value of an annuity due of $1. An annuity due means the first payment is received on the present value date, right, or the beginning of the first year, the beginning of every year. So the payments here would be received on the 5 payments would be received on December 31, 2016, 17, 18, 19, and 20. Okay, we're still assuming that 12% annual interest rate for 5 periods. So we'll come across to 12% down to 5 periods. We get 4.03735. And we're going to multiply by the $5,000. Okay, so that $25,000 to be received, $5,000 today, and then $5,000 every year for the next 4 years afterwards, would only be worth $20,187 in today's dollars. Now the third situation is a little bit different because we're dealing with interest being compounded quarterly. So the number of periods is different for each future payment that we're going to receive. Okay. The first payment is received on December 31st, 2017. Interest is compounded quarterly. Okay, that's 1 year from our date here. This is first payment. $5,000. I think I was going to skip a row here. And so we'll go first payment, $5,000. Our interest rate, okay, it's 12% for a year. Divided by 4 quarters in the year, it's going to be 3% per quarter. All right, how many quarters from 12/31/17 back to 12/31/16? Well, only 4 interest payment periods. So we'll go to our table. You guys, we can't do the annuity table here. We have to go to the present value of $1 table, because our number of periods is different for each payment that we're going to receive. So we'll go to the present value of $1 table. Again, that's in the back of our textbook in the Appendix P. Present value of $1 table is on P-2. Okay, we're coming over to 3% and down to 4 periods. 0.88849 times our 5,000. So that 5,000 to be received 1 year from now, assuming interest is compounded quarterly at 3% per quarter. That's only worth $4,442 today. Okay, let's go to the second payment. Again, it's 5,000. Our interest rate per quarter is 3%. Okay, this second payment is going to be received on December 31, 2018. So that's 2 years. times 4 quarters per year gets us 8 interest payment periods. So we'll go to the present value of $1 table, the 3% column, and come down to 8 interest payment periods. 0.78941 times our 5,000, $3,947. That 5,000 received 2 years from now is only worth $3,947 today, assuming interest is compounded quarterly at 3% per quarter. Okay, our third payment will be received on December 31, 2019. Again, that's 5,000, 3% per quarter. Okay, 3 years times 4 quarters per year would be 12 quarters. So we come down in the 3% column on present value of $1 table. We get to 12 periods, 0.70138. And we'll multiply by the 5,000. Okay, 5,000 received 3 years from now, assuming interest is compounded quarterly and the interest rate per quarter is 3%. That's only worth $3,507 today. The fourth payment which would be received on December 31, 2020. No relation to the television show. Alright, if we're dealing with 4 years from now, 4 quarters per year, so that's 16 quarters. So we go to our table, 3% column, come down to 16. We get 0.62317. Times 5,000. Present value there is 3116. So 5,000 received 4 years from now, assuming interest is compounded quarterly at a quarterly rate of 3%. It's only worth $3,116 today. The opposite would be true if we invested $3,116 today at an interest rate of 3% per quarter with interest compounded quarterly. At the end of 4 years, we'd have $5,000. And then the fifth payment of 5,000, 3%. All right, now 5 years, 4 quarters per year, we're dealing with 20 interest payment periods or 20 quarters. All right, so 3%, 20 quarters equals 0.55368. And we're going to multiply by the 5,000. All right, so that 5,000 received 5 years from 12/31/16 is only worth $2,768 in today's dollars, assuming interest is compounded quarterly and interest per quarter is 3%. I hope you understand where the 3% came from. If it's 12% for a year, divide that by 4, it's 3% for a quarter. Now we'll add all those together. The present value of all those future payments of all 5 of those future payments of $5,000 each is $17,781. So what do we know here? In total, we're receiving $25,000 over the next 5 years in annual increments. But if we assume interest is compounded quarterly, 12% per year. That $5,000 to be received over 5 years is only worth $17,781 today. Of course, the opposite would be true if we invested $5,000 a year at the end of every year for 5 years, with interest compounded quarterly at 3% per quarter. At the end of the 5 years, we'd have $25,000. These would work that way individually. You'd come back to the $5,000. Okay, and this would be the amount you'd have to invest each year to get to that $25,000. All right, you guys, after working this one, I don't think you'll have any problem with a homework problem 6-8 on the Connect site. If you have any questions, please be in touch. Thanks.